Hey out there, everybody. Welcome to OpenCV Live. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you, my dear friends, can call me Phil. And we are here this week with Kwabena Agyeman, the founder of OpenMV, who makes amazing, low-cost, low-power cameras that have Python inside for microcontrollers. They've been around for several years. We've had them on the show a few times, and we're looking forward to a catch-up. Fun fact, Kwabena lives one block away from me, so we could have done this interview in person, but due to extreme laziness on my part, we are
Yes.
not. Speaking of extreme laziness, Dr. Satya Malik is not joining us today. I'm kidding. He is on assignment. He's traveling. We will have the good doctor back next week, hopefully. But who knows? The busy life of a CEO, something I'm sure that our guest is well familiar with. If this is your first time joining us or you just need a few reminders, one thing we do on this show every single week is take questions from you in the audience. Use the Zoom Q&A button or the chat system wherever you're watching to ask questions during the show. We'll do our best to flow them into the conversation. We'll also save some time at the end of the show to try to answer questions that we have not gotten to. We're also giving something away to you in the audience. On this episode of OpenCV Live, like every episode, later on in the show, I will be doing a trivia giveaway. One question, the first person to answer it correctly will win the OpenCV course of their choosing. You can see what courses are available by going to opencv.org/university. Even if you don't win today, check out OpenCV University. Maybe invest in yourself this year, upskill, get the new job you want, get paid more at your current job. OpenCV University can help you do all of these things if you put the work in. Before we get started proper with presentation, I've got a couple more little bits of OpenCV business I want to discuss. Up at the top here, we're coming up on some deadlines that folks need to be aware of. One of which is Google Summer of Code. OpenCV has been honored to be selected to participate in Google Summer of Code for the last many years, and we really do appreciate Google giving us that support. Many awesome things have been added to the OpenCV library as a result, including huge updates and improvements to the DNN module in previous years. I believe some barcode scanning optimizations were added last year. Regardless, Google Summer of Code contributor applications are open until April 2nd. If you are a student anywhere in the world, you can go to summerofcode.withgoogle.com and you can apply to work on some cool OpenCV projects over the summer. Also, this year with Google Summer of Code, the computer vision annotation tool has been selected. And so maybe if OpenCV is not your bag, you want to work on improving CVAT, another great open source tool that many people benefit from out there, possibly including you watching this right now. So go check out Google Summer of Code. Apply if you're passionate about this stuff. Looks great on a resume, and you will get some high quality mentorship from industry professionals, which for folks that have been in the industry know that it's tough to get a lot of these people's time. And so being able to actually, interact with them and learn from some of the top names in the field of computer vision and AI is an opportunity that does not come very often. So please check it out. We've also got the OpenCV workboard. OpenCV 5.0 is in progress. We are every day the team is working on features for the biggest release of the biggest computer vision library in the world. You can see the to-dos, what's being worked on, what's done. We're also doing blog posts on opencv.org summarizing the changes every week. This week's update will come after this show, in fact. Lots of things are starting to sort of snowball here and really get rolling after a few weeks of doing a lot of the background work that is required before you really start crushing code. And the team has really started going here. We've got 20 closed tickets. Obviously, the best way to follow this is to go to the GitHub workboard. It's github.com/orgs/OpenCV. Stay abreast of the updates and how things are going whenever you want by checking that out. OpenCV is a nonprofit organization that makes an open source computer vision library. If you've got a few bucks to spare, you can support OpenCV directly, financially, by going to opencv.org/support and donating via Stripe or PayPal. OpenCV is a 501c3 registered nonprofit organization in the United States, which means that if you are in the US and you donate, it's very likely that you can claim this on your taxes. So if you send us a donation, hit me up at phil@opencv.org, and I can probably send you a tax receipt. It won't help you on this year's taxes, obviously, but because I'm sure many of you are in the painful process of doing this year's taxes or this quarter's taxes, if you're a freelancer like myself, you want to make sure that you do your best to make next year's pain just a little bit less. And you can do that maybe by giving OpenCV a couple of bucks. If you're part of an organization that benefits greatly from OpenCV and you want to contribute to OpenCV to keep the lights on in this little nonprofit organization we have here, we've got 3 levels of sponsorship for organizations. There's bronze at $6,000 a year, silver at $30,000 a year, and gold at $100,000 a year. This gets you quite a few perks. For example, appearances on OpenCV Live, blog posts on opencv.org. We will help syndicate your content to the engaged OpenCV audience pending editorial approval, of course. It's me, I'm editorial approval. So check that out if your organization uses OpenCV and wants to give back a little bit to the community. Even if you can't give back financially, maybe your organization has significant engineering resources and you want to devote some of those resources to help work on OpenCV. That would be rad as well. Please send an email to phil@opencv.org if that describes your organization, and we can talk and see what we can do together. Thanks so much for considering becoming an OpenCV sponsor. You can also sponsor OpenCV on GitHub. You can go to github.com/sponsor/OpenCV, and for $9 a month, you can join the 12 incredible human beings who are currently supporting OpenCV on GitHub. That's a new record, by the way, 12. Excellent, I love it. Thanks so much, everybody out there, for doing that. You can also buy a t-shirt. OpenCV's got swag now. We've got merchandise, folks. T-shirts, buttons, pins, tote bags, pet bandanas. I'm deeply, deeply disappointed in every one of you because I have not received a single photo of a pet in a pet bandana yet. Get on it. Get on it. You can also become an OpenCV volunteer. OpenCV is building out our volunteer program. If you're a student or a professional or just some person that is a freelancer building their own cool little OpenCV based projects, maybe you've got a couple hours to spare every week. Maybe you want to help promote OpenCV. Maybe you want to help us with documentation. Maybe you want to help organize an OpenCV meetup at your school. These are all great reasons to become an OpenCV volunteer. Please check out the opencv.org/support page for a link on how to become an OpenCV volunteer. If you're watching this anywhere else, OpenCV has a YouTube channel, youtube.com/@OpenCVofficial. This is where you'll find the recordings for every episode of OpenCV Live. We're also on LinkedIn. We're streaming on LinkedIn as we are on YouTube. We've also got Blue Sky. We got the new stuff out here, folks. We're not stagnating on the failing Twitter platform. We're on Blue Sky. We're on Mastodon. We're on LinkedIn. We're everywhere. With that, I think now is a great time to pitch to Kwabena. Kwabena, welcome to the show. Please, tell the folks who you are and give us a little bit of history of OpenMV. It's really impressive what you've been able to do with a very, very resource constrained. I feel like you're kind of amazing.
Thank you. Yeah, resource constrained. Just me and my co-founder really working on this platform now for quite a long time, but with some success and improving momentum. So I'll get started. Hi, everybody. I'm Kwabena. I run a company called OpenMV, and we've been doing computer vision on microcontrollers for about 8+ years now. Actually longer though, because before I got into OpenMV, I was doing something called the CMU Cam. I built the CMU Cam 4 back in the day. If you ever remember the CMU Cam sensors, these were the first like microcontroller computer vision sensors, and they were released back in 2000 more or less.
This was way before Arduino or Raspberry Pi had existed in some cases, but definitely before there were camera modules at that that size and 4 MCU.
Oh yeah, absolutely. These things are running on I think a XX48 or something. It was seriously an 8-bit microcontroller architecture. I remember looking at the system, and it's so simple compared to the MCUs we now deal with. it's a cool job running this company and doing stuff on microcontrollers because these little processors have gotten ridiculously powerful actually lately. They're actually kind of coming on the. I think about my first computer where I played StarCraft on, and that now fits in a $4 chip basically. That's kind of the level of silicon scale that's been happening. Pentium 3 processor with all the SD-RAM and everything you had and hard drive now, that's in a whole embedded system this big. So I've got a presentation to share. So let me try to switch over to that just to get it started. Okay.
Sounds great.
All right. Can you see my presentation? Is it coming through?
I can see the screen. We're coming through, Dimitri.
Okay, great. Which one do I hit?
That's a Dr. Strangelove reference for y'all out there.
Ah. All right, OpenMV. So we make something called the OpenMV Cam, and we are developing a computer vision library like OpenCV, but our focus is on embedded systems that have no operating system, so bare metal. Pretty much everything is just running total control on the system. And these are for microcontrollers that are small computers in everything. So our most recent product is the OpenMVCam RT1062 built on a Cortex M7 processor. And this is a 600 megahertz CPU with 32 megabytes of SD-RAM. Again, fun fact, Windows XP, that's the minimum requirements you need to run Windows XP, actually.
Wow.
So could this run Windows XP? Potentially. Would you want to try to make that happen, though? Probably not. But it definitely can run Doom. Anyway,
I mean,
so
you might be underestimating just how much I love and miss Sid Meier's Sim Golf.
probably could put SimCity on it,
It
definitely.
doesn't,
Or
this is one of those things I'm going to hijack for just one moment.
yeah.
I think a lot of people are familiar with Wine, the Windows compatibility layer for Linux and Mac OS. There's some games that because of the way that they were developed at the time, they do not work still on Wine, and you have to basically have a Windows XP or Windows 2000 installed to play them. One of which is Sid Meier's Sim Golf, one of my all-time favorite games. So for a while, I had a little, desktop like Packard Bell computer just to play that game in my apartment.
Mm. That's a lot of work to maintain,
You know,
especially since
hey,
computers sometimes randomly die when they get that old.
the heart wants what it wants, man.
That's true. Um, All right. Anyway, to continue, yeah. So what we do is basically it's a full computer vision library similar to OpenCV, mainly just like the image processing module, not necessarily all the extra algorithms. We try to fit everything actually within to about a 2 to 4 megabytes of flash space. So if you think about that, yes, you can do most of the algorithms on OpenCV within 2 to 4 megabytes of flash because at the end of the day, most of them just have really tight loops and aren't actually a lot of lines of code in particular. The things that are huge are the data structures that you need to store, like ML models. That's where you start using up a lot of space real quick. Um, and then, one thing we've been doing, which is definitely new for folks in the microcontroller world, is actually trying to do SIMD optimized coding. A fun fact, a lot of these MCUs that are out in the world, they actually support something called Cortex SIMD instruction sets. And this allows you to do 2 instructions per clock, sometimes up to 4. It's very limited compared to desktop SIMD, but this is widely deployed on billions of MCUs. And this actually lets you get, again, 2 to 4x the performance on these microcontrollers. But it's going to change in the future because ARM just released this new processor called the Cortex M55. They came out with it back in 2020, but it's finally made its way into chips now this year. And basically, microcontrollers are going to have vector DSP instructions similar to ARM Neon. So this is about 1,000 new instructions to the instruction set. And this actually improves the processing performance from 2 to 4 data values you can operate on a time to up to 16 actually.
That's
And so
pretty
just think
huge.
about those as like clock multipliers. So that 600 megahertz CPU I'm showing you is actually 1.2 gigahertz. And then once you bring in the neon, well, the new helium instruction set for new systems, that 600 megahertz, will, be multiplied by 8 then. And so you're really getting into, application processor territory in terms of performance, but still on an MCU that's bare metal, where you control everything directly. Now, why are MCUs
It's
interesting? Well, one
it's
of
really
the
impressive how quickly I feel like the last couple of years the efficiency of these processors has really like kicked off. I'm building a little cyberdeck project in my spare time just based on
Mhm,
the Pi Zero 2, and holy moly, like it's wild how fast that thing is for like $10.
mhm.
And I've got a heat sink on it, so I'm not worried about thermal issues or whatever. But I mean, you can really tax like that thing will run on a very small battery for hours and hours and hours at pretty good speed. Like you can play some. It definitely runs Doom.
Oh yeah, yeah,
That's for
absolutely.
you could probably run 7 or 8 Dooms at a time on this little guy. It's incredible.
Hmm. But what if you could do it without a heatsink? That's the promise of
Yes, yes.
microcontrollers. You're drawing something on the order of 100 milliamperes, and the newer ones that are even faster, surprisingly, they draw less power thanks to just lower voltage rails and such.
Yeah.
So you're looking at like 20, 30 milliamperes for, the even more performance.
Which is just
Um,
a tiny, tiny amount of
yeah.
electricity. Like I don't,
Mhm.
folks that are, they might. Can you think of a good way to describe that to people? Like the comparison, because if they're not electricians, or engineers, they might not get just how tiny that is.
Yeah, yeah. Let me think. Let me think. What's a good comparison? Um, well, okay, so let's do wattage. Like your standard laptop is 65 watts power adapter. And so this is one. This is less than one. This is like zero point 0.3 watts or so. So that's the best way to think about it. Your computer needs 65, this needs zero point 0.3. So it's a couple orders of magnitude in difference.
Wild.
Um, but that's actually really important. The next point I wanted to mention is the power draw in deep sleep is where we've been seeing a lot of people really interested in these products. Particularly, it's this kind of super loop people want to do where they want to have something that's on a battery, it's in a really low power state, and then an event happens. It wakes up into a higher power state. It takes a picture. It does some ML on that picture to figure out what's happening, and then it would transmit that image to somewhere else, and then it goes back into sleep. And that's where we see a lot of people looking at this technology for that reason. And to help enable that to transmit the image somewhere, we really built in a lot of connectivity. So Ethernet, Wi-Fi, Bluetooth, USB, SPI bus, I2C. So everything you need to really get to wherever the heck you're going with that data.
Yeah, one of
And
the one of the great use cases for that, what you're
mhm,
describing here that we've seen in previous OpenCV competitions and even in the news is conservation. Like basically like spotting poachers and things like this in various parts of like Africa and other places in the world where there's not a ton of people around, not a ton of like connectivity or ways to really do it, and it's also kind of dangerous, for humans to
mhm.
be just kind of out there. Number one, poachers don't like being caught. Number two, those animals are big and you're kind of on their turf. And so this sort of thing is really essential to a lot of environmental concerns and improvements that we as technologists can bring to the world. So it's really awesome to see.
Oh yeah, no, definitely. We actually have quite a few customers who are actually using the OpenMV cam in that way because it kind of is a direct fit for them. The low power point being the most important. It's a challenge when you need to. So when I say we can go to microamps of power, so when you go to the microamp level, a battery. Uh, let's see. At the microamp level, a battery this big will last you 5 years of runtime
That's nuts.
in low power mode. So when people talk conservation cameras, they'll load it up with maybe a 20 or 30x this much battery power. And pretty much you'll have a system where you can deploy it and realistically 5 years later come back and it'll still be on that same battery.
That's wild.
Um,
Like it's interesting
yeah.
because on some of those batteries that's actually beyond the expected lifespan of the battery. Like it will never complete a full discharge cycle in its life. That's kind of interesting.
Yeah, that's the goal. If you actually want to have something deployed, and it's what's interesting about these types of applications is one of the things to understand is when you have a large amount of power consumption, you have to actually link yourself to typically to some power input source to get power. PoE, for example, might be a way to do that. But so I'm the president of my HOA where I live, and I didn't want to be the president. It was just there weren't that many owners in my building, so I got signed up by the all other HOA members, and it basically means I act as a super for free, fixing light bulbs and other stuff. And most
Nice.
recently, the garbage can overflowed, and someone had to go into the garbage room and pick it up. So it's not all a fun and games job, but one of the things that I had to deal with was we needed to add some security cameras, and just like doing the quoting for the security cameras, guess what? The security cameras themselves were $100 each, and it was $5,000 to run the conduit
And
for the Ethernet.
that's pretty common pricing. Yeah.
Yeah, and when you think about that, you realize, when you have to build out infrastructure in the real world for actual systems, it costs a lot of money, especially labor for folks to do custom stuff like that, to just run metal conduit with Ethernet cables. You can actually end up being like just the cable itself, and that conduit can end up being much more expensive than the sweet hardware you designed that's supposed to be sexy and do something. You might be not unable to complete the project because you can't actually get a Ethernet cable and power to it easily. Looks like we got some questions in the chat. Oh, no, nothing's there. Okay, cool.
Not yet.
Um,
Well, yeah, keep going.
okay, keep going. So, why am I so excited about this? I'll tell you one thing. So, I used to be part-time on OpenMV. Just basically side hustling this for the last 7 years, basically. So, it's a dream. Hey, we like playing around with these things. They were cool. And then people started being interested. And then I started working harder on it. And we've been optimizing code and going for a long time. And, they're actually starting to get pretty decent. Like our performance, we're pushing these processors to the limit. I'll say this, we've actually made our current system like 4 times faster with the same processor just by one, better frame buffer architecture. So we're not dropping every other frame, instant 2x, frame rate boost. Then DMA offloads where the CPU wasn't capturing each line of pixels at a time. So freeing up 50% of the processor's performance. So doubling again, and then, learning how to write algorithms better where we don't waste a huge amount of CPU time redoing the same amount of work. And then adding SIMD performance to algorithms. And it's just been, if you look at our code base from 5 years ago, the same the same microcontroller, the same base hardware system will be on the order of 2 to 3x to 4x faster with just code changes. And it's crazy that you can have that much performance by just being better at understanding what you're doing.
Well, and
um,
that's also, I think, an important difference between those are the kind of gains you really only get when you're not part-time, when you're like kind of all in because you have the time to do it, or you're taking the time, making the time to do it, and so it's really awesome to see.
yeah, no, it definitely is. I did a lot of those part-time, but that's what's setting me up to think about doing it full-time now is realizing, I thought these things were just slow and whatever. It was cool that we could do this, kind of coding, but then starting to realize that they could actually be competitive with application processors it's kind of the insight that makes me want to go full-time on this and give it my all so that we can see what happens. And I say this is important because microcontrollers, they're kind of big. You don't think about them often, but they actually eclipse Linux-based processors significantly. It's a $44 billion market. Well, it will be in 2030. In 2022, 3.2 billion of these things were shipped. Now, of course, all of them
Yowza.
weren't like high-end devices. Like a lot of them were like a microcontroller in your remote, but they are literally everywhere. I mean, if you've ever used an Arduino to blink a LED, you'll know what I mean. Like that used to be a 555 timer.
Yeah.
People put a lot of effort into designing electronics, and nowadays the thing is throw a microcontroller on it, write some code, microcontroller does the thing. No one's
It,
doing integral like PID control using op amps anymore like they did back in the 70s. That's not a thing.
and in many cases, it's cheaper to throw a microcontroller at it than to buy a 555 timer chip.
Oh, it is. It's cheaper, easier. It's just, this is the nature of things. People use MCUs everywhere. And if you need one that's hardened and radiation tolerant or whatever for some crazy app, you can do that too. The lower end MCUs are fine for, applications where you say, I want to do everything in analog. Anyway, so historically, these have been basic processors. They just had like 8 bits of performance and etc. They weren't that interesting, but not anymore. The latest ones coming out in 2024 are like at the 16 nanometer FinFET node. They got megabytes of RAM on board that run at gigabytes a second. Like you'll have a 800 megahertz system bus that's running at 128 bits at a time, 128 bits to 64 bits at a time on some MCUs. And that's giving you 3.2 to 6 gigabytes a second or so of bandwidth on the microcontroller. And that's
Spicy.
drawing, that's drawing milliamps of power. Um, and if you can fit your application, by the way, into that internal system RAM, you don't need SD RAM anymore, which cost a lot of power. Like, DDR4 RAM is not it's pretty power hungry and it requires board space.
And it's one more thing that can fail.
Yes, that's true. You also have megabytes of flash on board some of these MCUs. Not all the case, not always. Typically, they try to locate it externally to do execute in place, but there's some that have megabytes of flash or flash equivalent. Let me not say it's flash. I think it's flash equivalent at that lower when you start getting into that fine node process geometry. But they're also including neural network accelerators. This is the big crazy thing. So there's stuff. ARM has they're releasing this M55 core that has vector DSPs, so it can do 8 to 16 values at a time with SIMD. And then again, they're also putting the Ethos U55 ML accelerator, and so this gives you something on the order of 200 to 600 gigaflops of performance. This actually, Raspberry Pi 5 full bore, all cores running at maximum, you're at 100 gigaflops. And
That's
that's
quite
drawing,
floppy.
yeah, and that's drawing, all the power with a huge heatsink on that. And you'll have microcontrollers that are going to draw almost no power, outperforming it. That's not to say that, the next version of the Raspberry Pi can just include a specialized accelerator, which would very easily get it to that level of performance. But you're seeing these things now coming down on chips that are going to be on the order of $4 or so. Um, and even better, specialized hardware now for actual image stuff. So we want H.264 on a microcontroller, other stuff like that. I don't know. I mean, who knows what's going to be happening? But vendors are starting to release things in the future for this kind of stuff. We see it everywhere. It's definitely been happening, in China from other various IP vendors and such. And so 2024 and 2025, we're going to see these things coming on board. And so this is where OpenMV comes in. There's no standardized library of software for all of this stuff. It's kind of like, hey, there's SDK, rewrite it yourself, figure out your own application, fight all the DMA controllers. There's something called cache coherency you have to deal with, which is something that's very, very brutal if you don't understand how machines work at the lowest level. Lots of great gotchas and issues. And so uh, OpenMV, really, we want to be that software library to kind of make that easy for folks, which it's kind of like a OpenCV mixture, but it includes a focus on camera drivers, processor drivers, kind of the whole kit, the whole kitchen sink. So you can just focus on writing some code versus having to build an entire operating system from scratch. See, we got a question so far.
Yeah, I see that. Antonius would like to know a little bit about Arduino compatibility with OpenMV and asking about C or C++ code with OpenMV.
Yeah, yeah. So we're actually we have all our code base is in C, but we're built on something called MicroPython, so it is not a Arduino programmable device. There's a reason for that. The firmware images we ship are on the order of a couple megabytes or so to run the whole thing. And so if you think about the Arduino-esque programming experience, you'd be reflashing a couple, megabyte large image each time you want to make a change. Instead, with MicroPython, which is also a pretty popular system nowadays, it's you just send a Python script that kind of at high level tells the system what to do. And one of the things to note about that is uh, you can write like our firmware is totally open source, so you can go in there and do all kinds of crazy stuff, whatever you want. But we have like the easy mode layer, which is MicroPython. And using Python is really, really valuable. Just, data structures, dealing with malloc free, all that kind of stuff. That would be really nasty, right? If you had to, if you have like a image function, return a list of objects that you have to manually garbage collect yourself. That'd be a lot harder for most people. And so Python just
Hmm.
lets you, easily forget about that, and garbage collection will run and clean it up for you.
Yeah, MicroPython's great. I've done a few projects with CircuitPy and a couple of other. Just being a Python guy in general, and OpenCV has a very popular Python flavor of the library as well. It's really great to just be able to directly port that knowledge over into working on a completely different system, which is one of the great, I think, one of the great things about Python in general.
Yeah, no, absolutely. What we see for our power developers is that they try to like go between the Python and C. So we have a lot of users who just stick in Python and ask us to fix bugs. But for anyone who's like, I need to get something done quickly, they actually like that, hey, I can get started in Python, it's easy. And then when I run into some issue I need some help on, or I need to customize the system, you can just jump into the firmware and start editing things as you feel like. And it makes it nice and easy to kind of play with. I added this slide. It probably is too much detail, but this is kind of like why I see this wave coming. Um, uh, Furthering on that previous piece of information I was talking about, microcontrollers becoming these super powered systems nowadays. It's kind of like you can have one chip to rule it all. So, what if you can, if you're building a system, what if you can save on your bill of materials by cutting out the need for extra RAM and cutting out the need for having an operating system and a hard drive? What if you could save on space? Physically, you need board space on a PCB to say, to add those two chips. And then what if you could save on power consumption? That's kind of where we see this trend going with these super powered MCUs. Is that when you shrink your application and you just make it really focused on doing that one thing it needs to do, you're going to be able to unlock these three different savings in one go. And I believe that that's going to start really changing things in the embedded world over the next 10 years. And so that's what I'm excited to see on how that shapes and unfolds. Got another question?
Yeah, I see one here. Nasser says TensorFlow in a microcontroller. It looks killer. Could you elaborate, please?
Oh, yeah, yeah. Actually, so Google released TensorFlow for microcontrollers a long time ago. We work with a company called Edge Impulse who basically operationalized that. So they started off with like pretty much the guys who helped generate TensorFlow for microcontrollers all left Google and then basically went to work at Edge Impulse. And more or less, they are the company that helps you do like they have like a RoboFlow like pipeline where you basically upload your image data, you train a neural network online, and then you download it, and you can just load it onto the system, and it can run. It can basically we have a TensorFlow library on board, and so that'll execute the neural network. And what's nice about that is the TensorFlow library in the future can directly utilize these, hundreds of gigaflops neural network accelerators. So on our current system, you may not be able to get the maximum performance you can get just because it's everything CPU done. But in future systems, you'll have that accelerator just turn on instantly and 100x performance on a different platform. Uh, yeah, I think we got Philip here.
Yeah. Philip would
What's
like to know just Philip says they're just starting out with computer vision. Do you have any suggestions for projects to that are sort of forward thinking, like toward 2030? Any projects for someone new in computer vision to, how can they prepare themselves for what's coming next versus what we have today?
coming next versus what we have today? Well, my focus is mainly just on the cost optimization and flow out of seeing these things appear in everything. So I would just say, like, think about where could computer vision go if cost and power consumption weren't a problem? Like, imagine this. Let's say you're playing golf and you build a
Sim
golf
golf.
cap that has two cameras in front of it on the golf cap, and it can actually track your golf shot, and that's only a $30 ad onto but you buy a golf cap and it's like the supreme version, and it costs $100, or also supreme would add a zero, so it's a thousand
I was
bucks
going
but
to say
anyway.
it's $1,000. Yeah.
No, that's too much. That's too much though. I'm talking about like regular person golf caps, so let's just say
That's
it's
but
Nike.
that's for the Supreme logo. It's
Yes, yeah.
the cap is $20. The logo is, 980.
Yes, absolutely. Okay, let's say it's a Nike cap though. But in the future, we could potentially have literally a camera in that in your in the front that hard edge on the front of a golf cap. and that could be tracking golf shots. I mean, the number of people who'd want to buy that, millions, that it's crazy what you could do when you free yourself from, okay, this thing's got to have a huge battery and it's going to have this certain PCB size and we can't make it flexible, and it has a fixed camera with a huge lens on it. And when you start getting into, oh wait, we're going to build this stuff into clothing, and we can build this into our light switch because it's gotten so cheap and low power. That's kind of what I try to keep your eye on, is where can we push computer vision to the edge, and then beyond the edge. Like right now when people say edge, it's still mounted to a wall. Like how can we get it off the wall,
Great,
that's a Michael Jackson song,
great
right?
Michael Jackson album, actually. Yeah, yeah, big
um
one.
and then we have Fiona. What's the
Finland.
estimated price of? So we sell our system for a little bit over $100. It used to be cheaper, but we had a lot of customers asking us for I/O interfaces, and so we realized that it's better to make it more expensive so you can connect it to anything than cut the price and have it have limited functionality. The base chip itself, though, is a lot less expensive. So these MCUs can be gotten from less than $10 to actually build something with. Uh, I try to
Here,
run
let
a
me.
company
I'll
though
take
where we
over the
have.
screen share for a moment here
Oh yeah.
and
Mhm.
share the OpenMV store here so people can get a little taste, as it were.
Are you
There
taking it
you go,
over?
folks.
Oh yeah.
Yep, there you go. So currently on the OpenMV products page, you want to tell us anything about these in particular? I see the RT1062 is the new kid on the blocks. Yeah,
Yeah. So RT1062, we hired a professional photographer to actually take good quality pictures. That's why it looks so good.
it's beautiful,
Um,
beautiful.
for that system, one of the things we really focused on was connectivity. So we added Ethernet on board, Wi-Fi, Bluetooth, basically USB high speed. There's secure crypto chips on board.
Hmm.
It basically is everything you need to have a development platform that can be put and deployed into IoT like applications.
Very
This
cool.
drove the cost up a little bit, but it was all for just making it easier for folks to actually be able to actually deploy this device into a real
Hmm.
environment.
Hmm.
So that was kind of our goal there, because when we first started doing this, it was more like, let's just slap an MCU on and a camera together and see what happens. And that works, but then a lot of folks are left with, when they want to actually build a product and scale this out, it becomes challenging because you can't connect it to the right stuff. And so we tried to
Hmm.
alleviate that with this system by actually having real connectivity built on board, which I'll demonstrate actually later in the show today.
It's killer that Wi-Fi is built in on that. That's a big deal. Yeah.
Yeah, no, it really helps. There's some examples of tracking. One of our
Hmm.
biggest selling features is blob tracking because it's super easy. It's a very easy to train classifier.
Yeah.
We've got a lot of kids who use our product actually for something called the RoboCup.
Yeah,
Um,
I'm familiar. For folks that aren't familiar,
mhm.
give them a little the Iggy on the RoboCup.
Oh yeah, more or less, they got a robot that needs to basically knock a ball into a goal, and so we've got that feature, covered. They use a elliptical mirror that kind of displays everything circularly around the camera, and then they just use color tracking to find the goal, and the robot's able to drive around and see 360 around it. There's a few other things here I want to mention. The Arduino Nicola Vision is kind of like a concept camera. Um, that we see folks that's been really popular. So this thing's the size of a postage stamp. So literally the size of a postage stamp. That's the whole
Wow.
system. It's got Wi-Fi, Bluetooth, USB
Yeah.
high speed, camera,
22 millimeters
microphone.
square. That's nuts.
Yep. And so this is what I mean by microcontrollers. Like you can make tiny systems, put them in anything. We're not. If you had to add the eMMC and if you had to add the SD-RAM, then all of a sudden that form factor doesn't work anymore, just because those two chips alone aren't going to fit into that package.
Hmm.
And this is where I talk about, hey, we're going to be able to put these things in all kinds of crazy systems because they're so tiny. And
Hmm.
yes, we do have barcode detection and QR decoding on board the
Hmm.
system, so you can do that kind of stuff.
Excellent.
Go back.
Yeah.
And then we had just some fun projects. So that, by the way, the H7 Plus and the H7R2, those are our older systems.
Hmm.
Those are cheaper because those just focused on no connection. Like basically, it's just microcontroller and camera and pretty simple.
Hmm.
But that's what I meant about the lack of connectivity. The challenge there is they're not able to get it online easily.
Hmm.
Um, And then one thing we did that was pretty interesting was a concept camera called the Pure Thermal OpenMV.
Let's see.
And so that one, microcontrollers actually can drive HDMI. I didn't know it was possible, but I gave it a shot, and it turns out they have an LCD bus interface,
Mm.
and we were able to actually output HDMI to a TV using a transmitter chip.
Wow.
And the idea here was to see like what could you do. You might want to skip ahead in the video. It looks like there's some.
Shout
Oh,
out
yeah,
to
there
our
you go.
friends at Hackster.io, the official community platform of OpenCV.
Yeah, so this one was actually showing off mixed thermal and color tracking at the same time. So you
Neat.
combine a FLIR Lepton with just a 5 megapixel camera. And then we added a display, and we also added battery charging, RAM on board, Wi-Fi. We kind of went overboard here. So it actually has too much stuff on it, and it really wasn't cost optimized. So this is my first time like getting into just, going at it and doing everything we wanted to do.
Yeah.
Um,
Yeah.
I learned from that though, which is, you do need to keep that price is a feature and not forget about that.
This is the OpenMV kitchen sink.
Yes, basically.
Got
Um,
it.
but yeah, it was fun to do.
Mm-hmm.
Um,
Mm-hmm. Got some nice lenses over here. We've got infrared filter lens. Yeah, yeah.
yeah, all kinds of stuff. One of the ideas with OpenMV here is that we just wanted to, most of the store
Mobile
products kind of
shutter.
help you enable your idea, like the FLIR Lepton adapter, so you can do thermal
Mm-hmm.
is one thing that people like a lot.
Mm-hmm.
Um, And then there's shields also you can buy to like do
I see
servo
this.
output
Yep.
and et cetera and
Excellent.
all that great stuff. Even TV, like FPV drones. We had people doing that back in the day.
Oh wow, it's great. Little yeah, CV was it CVBS or whatever the
Yeah.
yellow.
It,
Yeah.
you might think who does that, but it actually turns out it's a great way to have a little display because you can get a $15 LCD screen
Mm-hmm.
that, has NTSC in, and then people actually will build machine equipment where they'll take
Yep.
an open MV cam and just mount it in a production line. And they'll actually just have a little screen that's attached to it that shows off what it's doing
Yep.
as it's doing
Doesn't
computer
have to
vision.
be 1080p. They're just trying to make this. It's just for
No,
somebody to
this
glance at,
Yeah,
and be
they're just
like,
doing
hey,
like 640 by 480, or well,
yep,
really 320 by 240, and it
sure.
goes on a screen, and it's
Mhm.
just meant to be like if the camera is like looking at labels or something like that and verifying it. It's just to make sure the machine is not going crazy and doing the wrong stuff.
Right.
Um, anyway, can I take over again?
Yeah, please do.
Okay.
Actually, here we'll pause here before you share again, and we'll
Mhm.
do our trivia giveaway. We're about 12 minutes to the hour, so now is the time in the show where we give away something to you in the audience. I'm going to ask a trivia question based on the presentation from our esteemed guest, Kwabena Agyeman. The first person to answer that question correctly in the Zoom chat will win the OpenCV course of their choosing. If you have won in the last few months, please do not answer and give other people a chance to win. I'm talking to you, Partha. No, I think you're out of trivia jail. Actually, it's been a couple months, so we've got a trivia shark in here. Get ready to answer in the Zoom chat. So Kwabena talked a bit about his career and discussed the first camera that he worked on. What was the name of that camera? What was the name of that first camera? There we go.
Got it.
Pamudu, quickly, just like get out of my head. The answer was CMU Cam. CMU Cam was the answer to today's trivia question. Congratulations to Pamudu. Please send one email to phil@opencv.org. Go to opencv.org/university, pick a course, tell me the name of it, and we will make sure that you get access to it. Toot sweet. With that being done, Quab, take over again.
All right. Looks like we might go a little bit over, but that's good though.
Yeah, we were worried we were going to be light today, but turns out put the two of us together, we can talk.
Yes, absolutely. All right, let me answer some of these questions a little quickly before I
Yeah.
go ahead. Um, do you know if anyone has built 360 vision systems with your camera? Yeah, that's actually literally again what the people who do RoboClip do. They're not trying to do though the crazy dual camera, the dual lens thing where people do image stitching though. Instead, what they do is they just have a mirror that the camera looks at that's radial, and so when the camera stares up, the mirror kind of sends out. It basically has an image of everything that's around you in 360. And that allows people then in RoboCup to basically drive the robot in all directions with the Omni wheels that they have on those systems. To kind of find a ball and such. It's not really though about it's not like the 360 video you see when people are doing AR glasses and such. That's a different kind of application. Um, then people have def mono feeds. Um, Wait, let me see. There are ways to capture def from mono feeds. Do you guys experience with real-time def data? Yeah, so def data, it's been a challenge for us to look into. Right now, one of the issues of that is so doing stereo cameras, we definitely like doing the stereo coherency calculation. That's actually really CPU intensive. We had a customer actually build a shield that attached stereo cameras to the Arduino Portenta. And then I actually wrote, the basic stereo depth estimation, the same kind of one OpenCV has, and that ran at like 1 frame a second. It's really hard to do that in software, so there's a lot of hardware accelerators to do that kind of stuff, and that is not yet something microcontrollers have access to. There's also the problem of if you're doing something based on time of flight sensing, they're really those things require a lot of power. That's the general problem there that we've seen. Or you get into really specialized systems that are doing dot camera matrix and such. And just as 1 to 2 people in the company right now, it's really hard to focus on those applications without having a bigger organization. But it's definitely possible to integrate a depth camera feed. It would look like normal data. It's just a lot of engineering work to bring something like that to reality. Um, and then we got Brad here. What display could I use on my bike helmet that sees traffic behind me, or my golf cap that follows my ball? Yeah, I mean, if that's in pertains to the OpenMV cam, I mean, there's pretty much an infinite number of things that you could do there. We sell a little LCD shield. I can't say though that's exactly meant for what you want to do. You probably will need to do some more. I mean, if you want something that's actually like nice and doesn't look totally hacky, that's a harder problem to solve to set all that up.
It depends on how cyberpunk you want to look.
Yeah. And
It's a
then, yeah,
spectrum.
we got another question. Do you have plans to add a depth sensor, like in competitor real sense? Yeah, as I mentioned before, it's a lot of work to bring one of those to market. An incredible amount of work. But actually, what we're looking at, and the most realistic thing we would honestly do is that, companies like ST are actually releasing time of flight sensors that have 16 by 16 grid output coming soon to reality. So this
Which is
means
a
that
which is a folks might not be aware why that's a big deal. Could you kind of give them that scoop?
oh yeah, yeah. So right now there's time of flight sensors that are 1D. So they can measure about 2 meters with a little chip, and it can see about 2 meters ahead of it, and it's one dimensional. Now ST has one that is at 8 by 8, so it can see an 8 by 8 grid of 1D depth in front of it. And the most recent one they're about to come out with is a 16 by 16 grid of 1D depth. And you think about that, it's 2 meters. It doesn't really have enough detail to make out what the heck it's looking at, like shape wise. But if you combine that with camera data, it can then tell you exactly what that depth is of an object within 2 meters ahead of you, and then match that to the camera data. And those chips draw no power, and they're very tiny, and all the DSP and processing is inside them. So they're a lot more easy to integrate than having to deal with a separate camera and a dot matrix projector, or doing something that's active time of flight illumination.
Yeah, thanks for that. Miguel would like to know, do you have a GPS shield that could send location data?
Yeah, we're working on that actually. I can't answer any more, but we hope to have some product announcements soon in the future where we're able to offer GPS, cellular connectivity, and LoRa and other various features so you can get this thing online more easily.
Awesome. Love to
The
hear.
form factor of that time of flight module, you're looking at those sensors from ST. Look at the VLX sensor line, and they're basically on the order of like 3 millimeters by 3 millimeters or so, super tiny. All right. So before I go into a demo, I want to keep my time conscious here. Just want to mention our value and how long OpenMV has been around and such. So the way we've been kind of surviving is this is kind of like I'm full timing this business now versus it being a side hustle. But the way we've kind of been working is we have the OpenMV cam and accessories. This is basically the reference platform. It's sold into a long tail of applications and products. So we've got people buying these for literally random stuff all over the place. And we've shipped about 30,000 of these since we founded the company. Hopefully that number will go up though as I actually work full time here versus part time. And then we also do software and hardware licensing, which has really been helpful for us. Pretty much this is like the Arduino Nicola. That's our design, our firmware runs on that, but Arduino licensed us the idea and helped make it. And so they sell the hardware and we basically do the software support. And we've done over 70,000 units, more or less doing that. And these systems
Awesome.
go into all kinds of crazy stuff.
Total,
Yeah.
that's over 100K units total, my friend.
Yes, it is. It is. And I was surprised by that number, but then I
Congratulations.
looked up what our sales data was and I was like, wow, it's that high. I wish I, was making more money doing it. But selling hardware is not the margins aren't amazing unless you're selling like the top line stuff.
Right.
Um, yeah. But one thing I wanted to mention, why we're talking with OpenCV, and we have the same open in our name is that we are an open source company. We have everything online actually. So the desktop development software we use to program the cameras, along with the firmware itself, 100% open source. It's actually been nice though. It's helped kind of position us as a market leader in this kind of microcontroller computer vision space because we have some level of code quality and we have to make sure commits are done well, that we structure PR reviews and things like that. And it's like we have competitors who will take our code, clone it, not even clone it, sorry. They'll take our code, make a zip file, include it into their project, and then say it's OpenMV compatible. And it's let me see the Nassar. I think you can just go to openmv.io and then you
That's
can
right.
find everything there
Hmm.
on our website. Yeah, no, it's one of the things we've done is actually tried to do like a good software development process and maintain support for the products our customers buy. So all of our OpenMV cams, even from 2016, are still supported, and we still release firmware updates for them that improve the functionality. We're able to do that because we structured things in a way where, as we add new features, they go to all systems that can support them. And so this has allowed us to win partnerships and contracts with ARM, NXP, ST, Edge Impulse, Arduino, and more. And hopefully other, in the future, multi-billion-dollar customers, so I can make this into a real business. Um, just because we're trying to be the forefront in this mover and shaker that's basically delivering something akin to like OpenCV for microcontrollers, a standardized software library. All right,
Tremendous.
now demo time. Okay, too much
Oh,
talking.
yeah.
Okay. So I wanted to show off something fun. I'm going to share my whole screen now. Let's
Go for
do
it.
that.
I need to make a little sound effect for the Brave Live demo sound effect. If anybody out there, any musicians in the audience, you want to make something, send it to phil@opencv.org. We need a sound effect.
Okay, just checking my desktop to make sure nothing's important about to be leaked. All right, great. Can you see my desktop?
Sure can.
All right, so I've got my OpenMV cam over here to my left of me. So I'm just going to show that off real quick. Got my camera. So this is my OpenMV cam, and so it's sitting right there. We have it attached with a PoE shield. Basically with the RT1062, one thing we're about to release very soon is a PoE shield that gets this online. And we have it attached here via USB to my computer also, so I can command and control it. All
Makes
right.
sense.
Cool. So we're going to do a little script here. So one of the nice things you can do with OpenMV Cam is we have a RTSP video streamer library built into it. And so you can guess what I'm going to do next. This is kind of how the system looks. So we have this IDE called OpenMV IDE. It's similar to the Arduino-esque experience. So Basically you don't have to open terminals or anything to communicate with it. It's all integrated. You got your frame buffer here, your serial terminal, and your little text editor. Um, and basically, we're going to take this camera, turn it on. We're going to set the PIX format to JPEG, and we're going to set it to full 1080p. Set the image quality to 90% JPEG. And basically, this script is going to run a RTSP server that will stream video. So let's stop the thing, run it. And so the OpenMV cam now is getting a DHCP lease over the internet, over my local LAN. And so it's got this IP address. Great. And so then I can switch over to my text editor. So I got VS Code here. And thanks to ChatGPT, literally 5 minutes before this demo, I was able to ask it how to do video streaming via OpenCV.
Yeah.
And, of course, that's super easy to do. People have done it before. And so ChatGPT was like, boom, here's the code.
28 lines of code, including comments.
Yes, yes. Okay, great, cool. So let's just run that real quick and see what happens. Boom.
Wow, look at that.
So my OpenMV cam now is streaming video to the desktop.
Looks great. Yeah, that was, we last minute pip install OpenCV took about, what, 60 seconds? Something like that. And ChatGPT write us a RTSP streamer. It took another 30 seconds, and here we are.
So now here's the thing I wanted to show off. Now, see, this is just it's streaming video, right? So the thing to appreciate here is that, yeah, we could act like a normal camera. That ain't the point, though, of OpenMV. It's not to become a normal camera, even though you could do that. So if you wanted to do like a thermal camera streaming RTSP to, OpenCV, for example, you could do something. So as you see, Alcohol was mentioning why is it helpful. I just wanted to show a way that it was interfacing with it. More of the stuff we can do on board is like, let's say we want to do a TensorFlow object detection. We can run a face detector built in. And so let me improve the resolution a little bit here. All right. So we can actually do face detection on board. This is via something called the FOMO algorithm that's developed by Edge Impulse. So it's basically a image segmentation algorithm that's defining a grid of pixels per a grid of pixels that represent the centroid of faces in the image and such.
Very cool.
Yeah, but this is streaming over USB. The reason to show the RTSP system though is just to show that you can get things online, like moving those JPEGs and such. That's a lot of data, and so that's kind of what I wanted to get out there. Another nice feature, for example, is barcode detection or April tags. Actually, that's one of the things people like a lot.
Yeah, for robotics, super important. Also, lots of safety implementations. We'll use.
So got to go to a lower res on this because this is a very CPU intensive algorithm. We can turn up the res a little bit though on this system, so I'll do that in a sec. So list of April tags here, boom. Being able to detect all of those. Very simple for the system. Let's go up to a higher resolution. And so this is one of those fun features that, people actually really appreciate. It's like, we actually got the whole April tag library running on board.
That's great.
Yeah, so hold on there. Sorry, my computer has a little issue with the USB connection.
Computers, how do they work?
Yeah. So it's a fun system though for, one of the things like I was showing off there, just trivially being able to change the image resolution is one of those nice things you have. Let's see. We also have barcodes. That's one of the bigger things people like is the QR codes with lens zoom.
So I'm, for example, I've got my Raspberry Pi 02 based CyberDeck project I'm working on. Would you say OpenMV is a good solution for adding, video to that, or should I look to something a little dumber, perhaps?
Well, if you have a Raspberry Pi, I think the thing you'd want to do there is just directly attach a camera to it. It makes more sense to use the Pi cam, honestly.
Okay.
Where we get really interesting is when you want to have like a low power system and like the conservation level stuff, where
Right.
you need to kind of maintain that being able to be in a connected environment and being in some way where you need to run on that low power for a long time.
For long
Uh,
periods of time. Yeah.
yeah, it's a little bit hard to demonstrate it via live Zoom, but we can run scripts where you can on demand just drop this thing into a deep sleep mode. So, for example, there's a real time clock on board this system,
Excellent.
and so you can just say, okay, I want the real time clock to be this. Once you do that, then you can actually just shut the whole thing down and then wake it back up again after a certain amount of time and see
I
what the time
see.
is.
I see 2014. Is that the OpenMV epoch?
I think that's the MicroPython epoch actually.
Ah, okay. Okay.
Yeah, let's do this real quick. This is a boring demo, but it's kind of like what people actually care about when we have conversations with folks who are going to build a lot of units.
Yeah, show off.
Um, so it's okay. So let's set the time date here, 2014. Okay, we're print it. What is it? It's not called wake up. Hold on. Why isn't this example running? Uh,
Brave live demo sound effect.
yes. Let me just Google the docs here real quick.
Hey, I mean, if the docs are good enough that the founder uses them, that's saying something.
Yeah, it's okay. RTC. So there's this one annoying thing with MicroPython. There was a schism a while back where the folks MicroPython folks they have this so basically different processor architectures. There's something called the machine module and there's something called the PYB module, and so
Hmm.
we're still in the process of getting our code swapped between the two. So when you do in hardware, some of the code might work on the PYB module, but not the machine. Anyway, it's low level detail, but there's like two APIs that do the same thing because MicroPython abandoned one a long time ago, and that's the best way to say it. Um, so it's a pain that we're still going through that porting process.
Hey,
Anyway, okay, so this is the time it would have printed previously. Okay, and so the system just restarted. You could hear that bing, boom, boom, boom
yep.
sound. And let's see where it's going on now. So it should be about 10 seconds advanced or so from once it last on. Oops, I have to turn off that off. Oh yeah, okay. Yeah, so live demo. Yes, Brave live demo. Okay, so let's do this. Okay, so we're gonna connect, we're gonna run. Okay, so we see the time and date right here, 2000 this time. All right, and the system's back up, reconnected. Okay, and so now we're not going to set the RTC, and we're going to do that alarm setup. And we just need to make sure that
I'm a
we
little bit disappointed that you didn't set the time circuits to November 5th, 1955, but I'll let it go this time.
okay. And so let's go to sleep and give it 10 seconds, and it's going to wake up. Sorry, I'm just jazzing right now in the live demos. These are kind of boring, but yeah, this is the feature I wanted to show off. Anyway, okay,
It's the
cool.
code you don't write when you're jazz, you know?
Yeah, yeah. Anyway, so run it now, and you can see it's advanced by about 47 seconds. And the reason to show that off is that that was entering low power mode, the deep sleep, going down to the microamp current consumption. And so literally this is the feature that it doesn't sound that exciting, but this is the feature a lot of people like because again, when you hit that deep sleep instruction, you're down to 30 microamperes of power. You set a real-time clock time and you have the system wake up every minute, do something, then go back to sleep. And
Super,
that's how you
super low
get,
power.
yeah,
Yeah.
that's how you get years of battery life. It's by having some code like this. Um, Once you set that real-time clock date and that is running, you can, set and forget this system. And I showed off the RTSP functionality and such in image streaming, and that was to drive home the point that, we have the uRequest module on board in Python, so you can do, get and post request online.
Yeah.
So you can wake the system up every minute or whatever, have it connected internet, push an image online of what you see, and then go back to sleep. And so this is where
Mhm.
people in conservation labs and such really get jazzed about the system, because they'll actually, the deep sleep can be woken up not just by time, but an interrupt. And so it's possible to use a PIR motion detection sensor, for example, and that will be able to, when people move around or such, you can then wake the camera based up on that movement. And then when that happens, take a picture, do something, and then go back to sleep, basically.
Excellent. Muy excelente, as they would say in Espanol. We're about 10 minutes past the hour. Kwabena, if folks want to find you online and follow OpenMV, what are the best places and ways for them to do that?
Yeah, yeah. So you can find us at www.openmv.io. More or less, we sell hardware on our website, and we also have a blog. So we have a newsletter you can sign up for if you'd like to stay in touch with what we're doing, and see what's going on. So go to our website, and I encourage you to sign up for that. Let me just share my screen real quick for the website just to show you what I'm
Yeah,
talking
please
about.
do.
Um, okay, give me one sec. And we have a question that just came in.
Yes, I see that. Mayor, do you have a recommendation for battery which can be used with this cam, but for like wearable device applications?
So, I mean, honestly, with our new system, we really built ourselves around the SparkFun, the two-pin JST batteries that they kind of sell. So SparkFun has a huge number. They're pretty popular around the web anywhere. So
Yeah,
honestly,
see
it's
them a
like any
lot.
battery you want to use. Pretty much any 3.7 volt LiPo battery works. It's really not hard. Um, yeah, we try to make it as standard as possible and easy to use. So we have a newsletter sign up on our website, and so if you can sign up to that to get connected, we have Twitter. We also have a YouTube channel you can go to kind of follow us, and then also we got a blog, and so if you sign up for our
Sweet.
newsletter, you'll get blog updates as we release new stuff.
Excellent, excellent, excellent. Yeah, go check out OpenMV, follow, subscribe, smash that like button, etc., etc., etc.
All right, thank you.
Yeah, go ahead and unshare your screen there for me if you will.
Will.
I'll do our little outro. Yeah, so our guest next week will be Bart T, who will be showing us this awesome piece of recently released open source hardware and software, the Owl, an always on wearable AI device, sort of like that Rabbit device you've seen around, except this one runs locally and is on GitHub. Really excited to talk about this with Bart on the show next week. Join us for that. Don't forget to support OpenCV if you've got the inclination and the resources. We really, really do appreciate it. You can go to opencv.org/support to do that. If you're a student anywhere in the world, apply for Google Summer of Code. Applications are open until April 2nd. Check out the OpenCV5 workboard at github.com/orgs/OpenCV and follow us everywhere. We are on Blue Sky, Mastodon, YouTube, LinkedIn, etc., etc., etc. Take care of yourself out there, folks. Take care of somebody else if you can, and have a great day wherever you may be. Thanks so much for joining us. We'll see you next week.
Thank you.